You have a 1,200-foot roll of fencing and a large field. You want to make 2 paddocks by splitting a rectangular enclosure in half. What are the dimensions of the largest such enclosure? So we have a large rectangular enclosure. We split it in half. And all of the purple lines I just drew, that's fencing. Okay. So you have a big rectangular fenced in area, and then you add some fencing down the middle. So these 3 lengths are the same. And then we have Y across the top and the bottom. And the question is, what are the dimensions? That is, what is X and Y that will enclose the largest area? So you need 2 equations. Once you draw a picture and define variables, we need 2 equations. So I know that 1,200 feet of fencing means that when I add up these 5 lengths, I need to get 1,200. So I have 3 X's and 2 Y's, and that needs to add up to 1,200 feet of fencing. And then my other equation is for area. The area of this whole enclosure is just X times Y. And this is the one I want to maximize. Too many variables, right? So let's eliminate the Y by going to the other equation and solving for Y. So we have 2Y equals 1,200 minus 3X. Divide by 2, divide by 2, and I get Y equals 1,200 over 2 is 600. 3 over 2 is 1.5. So 600 minus 1.5 X. So then I'm going to plug that in to my other equation. Replace Y with the new expression that has X's in it. So I have area equals X times 600 minus 1.5X. Distribute, and I get 600X minus 1.5X squared. And this is a quadratic that opens down. It's quadratic because of the squared. It opens down because of the negative 1.5. That's a negative. And let's draw a sketch. So quadratic that opens down. Its y-intercept is going to be 0, 0, 0. So it looks something like that. And then X represents this length. That's on your x-axis. But your y-axis is area. So the vertex, which we typically call h comma k, h is an x coordinate, which means it represents the length or the width of the paddock. And then k is an area, which they did not ask us what the maximum area is. They just said what are the dimensions that will enclose the largest area. So I don't care about k in this case. I just need h. So h would be negative b, which is negative 600, over 2a, 2 times negative 1.5. So 600 over 3, that's 200. Okay, so x is 200. That's the x value that gives maximum area. And then y, I can calculate using this formula here that has y in terms of x. So y is 600 minus 1.5 times 200, which is 300. So 200 by 300.